Welcome to Saitechinfo channel, my dear students. In today's tutorial, I'll be discussing about how to write down the electronic configuration of nitrogen family elements. Let us discuss. That is, nitrogen is the first member of the family, and second we have phosphorus. Nitrogen, phosphorus, then arsenic. Okay. Then stibine, that is nothing but antimony. Then we have the metal bismuth. Let me take up nitrogen. Its atomic number is 7. And you just add 8, that is the octet configuration. So it has come across S block and P block. S has 2 electrons and the P orbital has 6 electrons. So 2 plus 6, 8. So it has come across the S block and P block when it jumps over to the next row. So you had to add 8. So 7 plus 8, that is 15. Do you understand? 7 plus 8, 15. Then from phosphorus to arsenic. Now it is in this group, is it not, nitrogen group? So it is in the third row. Arsenic is in the third row. So it has to come across the, again, P block, S block, then D block in this case. So we have to add 18 here. Why? Because S 2 electrons, P 6 electrons, D 10 electrons. So 2 plus 6, 8 plus 10, 15. So you had to add, that is 18 electrons. So 2 plus 6 plus 10. Okay. When you add this, you will get 33. So arsenic atomic number is 33. And then again you had to add 18 because when it goes from arsenic to stibine, it has to come across what? That is 18. So you can add 18 and you will get 51. That is the atomic number of stibine. Then from stibine to bismuth, it has to travel across D block. Therefore, F block also. So F has 14 electrons. So it has traveled S block, P block, D block and F block. So S 2 electrons, P 6 electrons, D, let us say S 2 electrons, P 6 electrons, D 10 electrons and F 14 electrons. So you need to add everything. So 2 plus 6, 8 plus 4, 12, 32. So you had to add 32 electrons to achieve the atomic number of bismuth. So 1 plus 2, 3, 5 plus 3, 8. I hope now you should be able to understand how to memorize. You need not memorize, just you should know the technique to get the atomic number. Done? Right. Now you must be able to write down the nearest inert gas configuration here. So let us write down the inert gas. Let us put Ig, inert gas. Which is the nearest inert gas? Helium. Helium, it has got 2 electrons. So helium. How many electrons it has? You can put like this, 2 for our convenience. Even though we are not write down the atomic number on the right side, but for our convenience we write here. So helium 2. So we have to account for how many electrons to account for 7 minus 2, 5 electrons. Okay. So similarly here 15, nearest is helium neon, and for neon, what is the atomic number of neon? It is 10. So the same logic can also be applied here. 2 plus 8, 10. Okay, helium neon argon. Okay, so argon is 10 plus 8, 18. Krypton, you have to add 18 here. So krypton 36 atomic number. Then xenon. Okay, so xenon is 54. How? 36 plus 18, that is 54. Okay, right. Now, that is 7 minus 2, we have to account for 5 electrons. Similarly here, that is 15 minus 10, again we have to account for 5 electrons. 33 minus 18, again we have to add 15 electrons here. We should account for 15, that is 10 plus 5. Is it not? Then what about this one? 51 minus 36, we should account for 15 electrons. And what about this? We should account for that is 29 electrons here. Why? Because 83 minus 54, that is 29. Okay. Now let us see how to account all these things. Now let us put, that is, let us write down the complete electronic configuration. So helium we know. So we have already accounted for helium, that is 2 electron. Now we have to account only for 5. So you can put, that is 5 means helium 2s2, 2p2. Very simple, 2s2, 2p3. Okay, so 3 plus 2, 5 plus this electron. So we have to account for 5 only. And you can write down simply neon. Okay, and account for 5 electrons. So 3s2, the next shell, is it not? So 3p3. And then neon argon. Okay, so write down argon. And we must account for 15, but it has come across D block, is it not? So in that case, we had to account for 3D, 10, and then put the next shell, 4s2, 4p3, okay, because 5 electrons. 10 plus 5, 15. Similarly, we have to account for 15 electrons, put krypton here, okay, krypton, and what we have to write? So 4D, 10, and write down the next electron level, that is principal quantum number, is it not? So 5s2, 5p6, 5p3, and xenon for bismuth. Okay, so write down here, that is we have to account for how many? 29. So 29 means, that is, you can split like this, is it not? 14 for F, and then D, 10. Yes, that is 2 and 3, is it not? So this is for F, and this one for D, and this is S, this is P. So 5, this must be 6S, 6P, and here 5D, and here 4F, very simple. So you can write down 4F, 14, and then 5D, 10, then 6S, 2, 6P, 3. Done. This is the way you can write down the electronic configuration. Okay. So you need not mug up anything, memorize anything. You should know the strategy to write down the electronic configuration based on the inert gas configuration and the common differences. You understand? Right. Thank you very much for watching this video.